Welcome everyone. Today we are going to see the demonstration of a quick lab managing deployments using Kubernetes engine. Before going further, let's understand what is Kubernetes engine or Google Kubernetes engine. It is an open source system for automating deployment, scaling and management of a containerized applications. Let's take an overview of this lab. As we all know that DevOps practices regularly use multiple deployments to manage application deployment scenarios. Some of them are continuous deployment, blue-green deployments, and canary deployments. This lab is to provide you practice in scaling and managing containers so you can accomplish these common scenarios where multiple heterogeneous deployments are being used. Let's move to the setup part. As instructed, let's start the lab. Here I am using the Quick Lab credits. You can use your monthly subscription to access this lab. Okay, we got the credentials. Now let's log into the lab. As given in the instructions, let's activate the Cloud Shell. Please do remember, whenever you start the Cloud Shell, don't forget to run these two commands. The first one is gcloud auth least, through which you can lease the active account name. And the second one is the gcloud config lease project, through which you can lease the project ID with your Cloud Shell. Let's run on the first command, which is gcloud auth least. The next one, gcloud config lease project. Now we are all set to use the Cloud Shell. The next step is we'll set the zone for this particular lab. We are using the US Central 1A zone. You can set the zone with this command. Let's copy this. Here we have given the sample code for creating and running containers and deployments. Basically, to get what container is, a container is a standard unit of a software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another after deployment. The deployment here represents a set of multiple identical pods with no unique identities. A deployment runs multiple replicas of your application and automatically replaces any instances that fail or become unresponsive. In this way, deployments helps ensure that one or more instances of your application are available to serve user requests. Let's run this command. It will take some time. Okay. Now, in the next step, we have to create a cluster with 5 nodes of N1 standard 1 type. Cluster is basically a set of nodes that run containerized applications. Let's copy this command. Paste. Okay, our cluster is created successfully. Okay, Now let's move to the next step. The next step is the next step is creating starting with the deployments. Through this kubectl command, we can get the details about the deployment object. Let's run this. Okay, you can go through this once. I'll move to the next command. You can see all the fields using this recursive option as well. Let's run this. Here we got the detailed information about all the things involved in our deployment object. Let's move to the next step. Yeah, this command will also help us to explain the command, and it will also help us to understand the structure of deployment object and what individual fields do. So let's run this one as well. Okay, here you got the detailed description again. You can go through this once. Now let's create a deployment. Here we are using the .yml configuration file. YAML is basically a data serialization language that is often utilized to create configuration files, and it works in concurrence with any programming language. You can simply understand it as a superset of a JSON. Here we are using a V editor. You can use any other editor like Nano editor to create a .yml file. Okay, let's copy and run this command. Whenever you are in V editor, before editing, you first have to click I, through which you will get a edit option, edit access basically, and then you can basically change anything which you want to. Here it is written that we have to change the image, so let's copy this. And okay, we have to change this image, the copied one. Yeah, to save this file, you just have to type go out, type escape, then you have to type :wq. It will successfully save whatever changes you made, as it is given here as well. Now let's see our changes. As you can see, we have successfully changed the image, and you can see it here. Let's move to the next step. Now we'll create a deployment object using kubectl create command. Let's copy this command. As we got the output as our object is created. Now we can verify this object by if it is created or not by kubectl get deployment command. Here you can see the object is ready to use and it is up to date as well. Now let's get the replica set in our deployment. Replica set's purpose is to maintain a stable set of replica pods. Pods are basically the smallest deployment objects in Kubernetes. You can also say it as a single instance of a running process in your cluster. It is often used to guarantee the availability of specified number of identical pods in the deployment. So let's run this command kubectl get replica sets. We got the output. So this command we can view the pods available in our replica set. Yeah, you can see here the status is running. So basically our pod is in the running state now. Now we'll create the authorization service using this command. Now whatever deployment we have created, we'll expose it. Using this command, we can expose the deployment we have created to the outer world. You can see here the external IP is still in pending state. You can run this command multiple times to get your external IP. Okay, we'll wait for some time. You can see here you got your external IP. Now in the next step, you can just see whether your external IP is responding or not using this command. Copy this command and we will replace this external IP with the original one. Yeah, we successfully got the message hello. Let's see our progress. So we have successfully completed our first step. Now let's scale this deployment using the kubectl explain deployment dot spec dot replicas command. As you can also see the version here. So this command we can update the different replica set. As you can see the message here, it is scaled. Now we will verify whether our 5 hello pods are running or not through this command. Yeah, we successfully got the output as 5, so our 5 pods are still running. Now we'll scale back the application. Now we'll again check the number of pods. Yeah, now we got it as 4. So here we have successfully learned Kubernetes deployments and how to manage and scale a group of pods. Now let's see what is rolling update is. Like as we know, deployment supports updating images to a newer version through a rolling update mechanism. When a deployment is updated with a new version, it creates a new replica set and slowly increases the number of replicas in the new replica set and as it decreases the replicas in the old replica set. Let's trigger a rolling update with this command. Firstly, we'll edit the deployment hello file. You have to change the image here. We have successfully edited the deployment hello file. Now let's see the new replica set created by Kubernetes. As we can see here, we got the 4 replica set with all in ready state. Now let's see the new history we got. Okay. Through this command, you can in the rolling update, if you detect any problem, you can also pause this rolling update using the kubectl rollout pause command. As we can see, we got the output as our rolling update is paused. You can check the current state of our rollout. Okay, our deployment hello has been successfully rolled out. Let's see the number of pods. Okay. You can resume your rolling update through this command. Our rolling update has successfully started again. As we again got the output as our deployment hello successfully rolled out. It means that a rolling update is successfully completed. Now sometimes we also get some bugs in our application. So assume that we got the bug created in our newer version. So since the newer version is presumed to have many problems, any users connected to those new pods will experience those issues. So in case if we want to roll back to the previous version, we can also do this using the rollout command. As you can see, we got the responses. Our update has been rolled back. We can verify. Yeah, you can see here. Here we can check whether our all pods have been rolled back to the previous versions or not. Yeah, it is rolled back to the previous versions. You can see here. Now let's next go to the next step, which is canary deployments. Like when you want to test a new deployment in a production with a subset of your users, you can use a canary deployment. Canary deployments allow you to release a change to a small subset of your users to mitigate risk associated with new releases. You can basically avoid the bug releases and all through the canary deployments. You can read about the canary deployments over here. Let's create a new canary deployment for the newer version. You can go through this once. Now we'll create the canary deployment with the kubectl create command. What the response is created. I'll verify the canary deployment is running or not. Now we successfully got our output as version 1. Let's check the progress. Since we have successfully completed the lab, let's see some of the additional steps. Here you can see some of the sub parts of the canary deployments in production, which is session affinity. You can go through this once after completing your lab. Let's go through the blue-green deployment once. You can basically understand this by reading this. Is like when we are doing the rolling updates, we may face bugs. So the blue deployment is basically the old deployment, and the green deployment is basically the newer deployment. Kubernetes achieves this by creating two separate deployments as it is written over here. You can go through this once to get a better understanding. We'll first update the service with this command. Okay, it is successfully configured. We'll first create the green deployment for the newer version. So our green deployment is successfully created. Let's see our current version is being used or not. Yeah, we successfully got the output as our first version. Let's update this to the newer version. Yeah, it is successfully configured. Let's see whether the green deployment is being used or not. Yeah, we successfully got the output as the version 2 as we have deployed the green for the newer version. Now let's see the rollback in the blue-green deployment. You can use this command again. Yeah, it is configured once again. Let's verify again whether the right version is being used or not. Yeah, we have successfully got our previous version back, which is the first version. And here you have successfully completed your lab with all the additional steps. Thank you. You can just go and end your lab.